Hello. So today we will talk about mass and volume. Okay. Hopefully you've heard of both of those words before. So first of all, what actually is mass? Mass is about how much stuff there is in something. Okay, so obviously stuff is not a scientific word. So mass is about how much stuff, or an actual scientific word, matter, there is in that object. Okay, now often students get confused between mass and weight. Okay, so when you say you're going to go weigh yourself and you get on your scales, or you're going to weigh, I don't know, some flour because you're going to do some baking and things like that, often it's measured in kilograms, but actually we're actually using the term weight incorrectly when we say sentences like that, because what we're actually doing is we're finding the mass of that object. So you're finding the mass of yourself when you step on the scales, or you're finding the mass of the flour or the sugar when you go to bake it, not the weight. So anything that is measured in kilograms is talking about the mass, not the weight, even though we say about weighing things. Okay, so just a reminder about what the difference is weight is about how much you're being pulled down due to gravity. Okay, so there is a link. The bigger the mass, the bigger the weight. However, if I went to the moon, my mass would stay the same. The amount of stuff or matter inside of me won't actually change. Doesn't matter if I go to Jupiter, Uranus, it doesn't matter. Okay, but with your weight, the weight is going to change because gravity is different on different planets or different celestial bodies. So my weight would be a lot less on the moon, because the moon is a lot smaller and its gravitational pull is a lot smaller. Okay, so mass always measured in kilograms, weight measured in newtons, because it is a force. Okay. So as I said, it's measured in kilograms. That's what we use in physics, but there are other units as well that you might have heard of, like ounces or stone or pounds. They're all mass as well. But I do want to focus on the kilogram, because that's what you're expected to use in science. Now, what they could do, however, is give something to you in grams instead of kilograms. Now, normally when we see that K, I always make you multiply by 1,000 first, because it means a kilo. This is the only time that I do not want you to do that. You need to change it into kilograms if it's not already. So this is the only time that when you see that K, you don't multiply by 1,000 first. So how many grams are there in a kilogram? Well, 1 kilogram is, you should be able to work that out because of that K, 1,000 grams. So how many kilograms do you think 100 grams will be? Well, it's going to be 0.1 kilograms. Okay, do you see that 100 is 10 times smaller than 1,000? So what's 10 times smaller than 1? It's 0.1. Okay, so that is how you would be expected to change between grams and kilograms. If it was 2,500 grams, you would need to change that into kilograms, and that's going to be 2.5 kilograms. Okay. So what else will you need to know? You'll need to know the approximate value of the mass of a human being, an adult, like an average adult human being. Obviously we all have different masses, and also the mass of a bag of sugar. Now, first of all, for a human being, I like to say, or I tend to go with about 70 kilograms. So average adult human being is approximately what did I say, 70 kilograms. However, I think it might be 80 kilograms on the PowerPoint that you're going to watch. So go with whatever it says on the PowerPoint. I tend to go with 70 kilograms, but that, you know, obviously this is just the average. Not everyone is 70 kilograms. Now for a bag of sugar, now if you are an avid tea drinker or maybe coffee, or I hope not at your age, or you like to bake, which I know some of you do, then you should be able to tell me that, you know, this bag of sugar, let me move it so you can actually see it a bit, how much that would be in kilograms. Now if you don't know, this is 1 kilogram. Okay, obviously, if you get a bigger bag of sugar, it's not going to be 1 kilogram, it's going to be more than a kilogram. If you manage to get a smaller bag of sugar, it'll be less than a kilogram. But when we say a bag of sugar, we're always talking about a kilogram, okay? So, bag of sugar, is 1 kilogram, okay? So that's it for what I want to talk about mass. So what I want to do now is talk about volume. So if I just move this all up a bit. Okay, volume. So what do we actually mean by volume? Well, if I drew, okay, obviously it's not the best circle you're ever going to see. It's not a perfect circle, but let's imagine it is. And I said to find what all of this is. I'm hoping you would know that that is the area of the circle. Okay, now volume doesn't really exist, well it doesn't exist actually, sorry, for 2D shapes. Because volume is a 3D property. So if we turn this into a ball, actually I happen to have one right here. If we turn that into a ball, it's I might get told off for saying this, but it's sort of similar to a 3D version of the area of it. So here we've got the area, the 3D version of it would be the volume. So how much space does this actually take up within within the air? How much space does it actually take up? Now, I'll tell you how to calculate a few common ones in a second, but I do want to talk to you. I wonder if I can draw a sphere even vaguely. Very badly. That's meant to be my 3D. I promise you I can do art, but the focus right now is physics, not art, so I promise you I can. So the units of volume are sometimes milliliters if we're talking about liquids. Now, while we're on that train of thought, 1 millimeter you should know is the same as 1 cubic centimeter, so they're interchangeable. So if I said how many cubic centimeters are 25 milliliters, you should be able to say it's 25 cubic centimeters or 25 centimeters cubed. I don't mind how you say that. That cubed is important, whereas the area, it would be 25 centimeters squared. Do you notice the difference? Okay, 2D, 3D. So yes, you can use milliliters, centimeters cubed, but most often we would use meters cubed or cubic meters. So just remember those, please. Now, I would like to just tell you how to calculate a few basic volumes. So again, this is not me doing my best artwork, but here is my cube. Let's call that W for width, L for length, and H for height. some of you might have already worked out how to calculate the volume, because a lot of you have heard this already. The volume of a cube or cuboid is length times width times height. So if I had a cube that was, I'm going to make some numbers up, 2 centimetres by 3 centimetres by 4 centimetres, just made that up. My volume would be 2 times 3 times 4, and that would give me 24 centimetres cubed. Okay, now for a sphere, I'm not going to draw a sphere again, so I'm just going to, because that was so rubbish the first time. So this is for cube or cuboid. For a sphere, we say the volume is equal to, this one's a little bit trickier to remember, 4/3 pi r cubed. Okay, now when you're doing this in your calculator, you can use the fraction button for the 4/3, or you can type in 4 divided by 3 brackets, that's fine. Pi is it's a Greek letter, but it stands for a number. I'm sure you already know that already. Now, there is already a pi button in your calculator. Normally you have to press shift, and then somewhere near the bottom you'll see a little orange pi symbol, and that's how you get pi on your calculator. And r cubed, what does r stand for? R stands for the radius of the sphere. So just like circles have a radius from the middle to the circumference, or the outside of the circle, that's the radius, so does a sphere. Okay, so there will still be, if I took the center of this ball to the outside of the ball, that would be the radius of the ball. So that's what I do. I remember to cube it, not times it by 3, that's not the same thing. I need to cube it, and again there will be a cube button on your calculator. Okay, that's it.